Okay, it's time to get started. Thank you everyone for joining our live lecture today. My name is Isaac and I'll be the lead instructor for the lecture. And today's topic is going to be web security. So let's go ahead and dive right in. So first thing is, let's talk about your mindset as a developer in regards to web security. Okay, so you should always have the mindset that you prepare for the worst, hope for the best, right? So you're always looking for opportunities to build your software in a way it's going to be more safeguarded. Okay, but that being said, let's talk about the degree of security that's needed for a software application. Okay, so every app is different. You might have, say, a small business like a restaurant approach you and say, I want you just to build a static menu website. And that's it. Something like that really wouldn't need a high level of security because there's no sensitive information involved. Whereas if that same customer came to you and said, I want, a menu along with, online ordering and payments and user accounts and all that stuff, well then, yeah, you would definitely need to, increase the level of security. So that being said, don't treat every project the same, right? And don't apply the same security standards to each project because they are all different. And so you'll need to treat each one as such. Okay, next let's talk about developer accountability. Okay, so as a developer, you have to be aware you're bound by certain laws when building projects within specific scopes. The two biggest being PCI compliance and HIPAA. Okay, so PCI compliance is simply the handling of credit card data. Okay, and the easiest way to remain PCI compliant is just don't ever let that credit card info hit your server. Okay, and the standard approach these days is a lot of developers use a third-party service such as Stripe or PayPal, so they remain in compliance and they don't have to, do any of that themselves. And then HIPAA, you probably heard of this, before you even got into software. This is, has to do with health information. So, if you're building, software that handles health data, make sure that you are up to date on the latest, specs regarding that. Okay, so for PCI compliance, you can go to PCI security standards.org. And for HIPAA, you can go to the HHS Gov site. Okay, and then some other information down here that is just a bad practice of, making, vulnerable. Okay, so social security numbers, addresses, that kind of stuff. Make sure, you also safeguard that as well. Okay, next let's talk about actors, okay, and building security around actors. So it's really hard just to approach software and say, I'm going to build this and I'm just going to magically know when to, put a security standard in place. That's probably not going to happen. So what helps is if you approach the software and think of things in terms of actors, okay? So when you're building a certain feature, ask yourself, who's the good and bad actors, okay? So a good actor would be someone like, the intended user, right, who's using it for its intended purpose. And a bad actor would be maybe an employee using the customer's payment info against them, right? So think in these terms, and it makes it a little easier to know when to implement a little tighter restrictions. Okay, next let's talk about trust boundaries. Okay, so these are different for every company and software app, but they generally are broken down into these categories. Okay, so we've got client server roles, network machine roles, boundaries, encrypted channels, and authentication, and areas of responsibility within a system. So let's go ahead and go over each of those. Okay, so let's start off by talking about what is a computer network. Okay, so a network is a collection of computers connected by a transmission medium. When you write software for the web, it'll end up being hosted on a web server. Clients may connect to your server, web browsers, native phone or native iPhone and Android apps, and anything else capable of sending network requests. Okay? So while this is an amazing thing, right, it connects the world around us, it also creates, backdoors and, vulnerable situations, right? So let's go ahead and talk about some of the things we can do to prevent against those. Okay, so channel encryption is one. So anyone on the same network can view all the traffic that you are sending and receiving. So in order to have private conversations between clients and servers, the channel must be encrypted. This can be accomplished using a TLS certificate and redirecting your web traffic from HTTP to HTTPS, and that S stands for secure. So there's a good amount of providers you can get these TLS certificate from. A couple big ones are Symantec, okay, and another one is Comodo. Okay, so next, let's go ahead and talk about API security, okay, and securing your endpoints. So because endpoints are generally publicly exposed, it's a good idea to set up some additional logic to verify the incoming API requests. Okay, so let's look at GitHub, for example, right? When we go to GitHub and when we are not logged in, we have the guest access, right? So we can look at public resources, but we can't look at anything else. Okay, and then when we are logged in, where we're authenticated as user, then we can look at public resources and own resources. And finally, if we're part of an organization, something like an admin, right, we can have access to even more endpoints. Okay, but you see, GitHub didn't set it up in a way where the guest just could access all the resources. So this way, it makes it more secure and harder for attackers to attack the more sensitive resources. Okay. Next, in regards to API security as well, is rate limits. Okay, so imposing your rate limit for requests made to your application API is a good way to ensure your site from getting attacked with several requests at once. Okay, so for example, if we go ahead and we copy the value of this curl request here, we'll just paste it right in our command line. You can see that sends that request, and we'll notice that it starts off with the rate limit of 60, and then after I send the request, I only have 59. Okay, so I believe with GitHub you only get like 60 in 1 hour, and so that makes it to where it's going to be really hard for me to flood their server with requests if I want to perform that kind of attack, because I have a rate limit. Okay, so make sure and impose one as needed in your own applications as well. Okay. So next, let's go a little bit more in depth about the DOS attack. Okay, so denial of service attack is what we were just referring to, is when we flood the targeted machine or resource with so many requests that either some or all are prevented from being fulfilled. Okay, so prevent against this, we have a couple different approaches. Okay, throttling is one. Okay, and that's limiting the bandwidth. Rate limiting is another, and that's the way we just saw in play with GitHub, right? So our endpoints aren't just vulnerable to any amount of requests. And then the web traffic monitoring is another option we can set up, to where they got real-time analytical tools these days, which will tell you when you see a sudden spike in traffic, and you can implement the best I guess procedures to mitigate the situation. Okay. So let's talk about a different kind of attack now. This is a different one called XSS, or cross-site scripting. And it's a type of computer security vulnerability typically found in web application. XSS enables attackers to inject client-side scripts, typically through an input of sorts, into web pages viewed by other users. Okay, so this is very bad, right? We never want them to be able to execute any script that we didn't write. So that being said, method we can use to prevent against this is something called sanitization. Okay, and there's a lot of libraries out there, so if you're dealing with inputs, you're more than likely going to have some sort of JavaScript library or something of that nature on the client side. But whatever the case may be, just make sure that you have some sort of prevention in place against this XSS attack. Okay, so SQL injections, another kind of attack that's very similar to XSS in the way that they normally use an entry field, some sort of like an input, but instead of script, they enter like a SQL statement. And because SQL statements are so close to plain English, a lot of times, they'll just, pass as plain English or whatever. And then, from there, they can, do a bunch of things with our database, dump the contents back to the attacker or whatever else, they might want. Okay, so a couple known prevention methods are sanitization. Okay, so that just goes what we just talked about, protecting your inputs. And then you could use object relational mapping tools as well. Okay, so let's go on and keep exploring these vulnerabilities. Okay, so one of the most commonly exploited web vulnerabilities is unrestricted file uploads. This can allow an attacker to upload an executable file, such as a PHP file, then call the corresponding URL from the web browser. They are now running code on your server. Okay, so again, if you are planning to include file uploads, whether it's for images or PNGs, whatever it might be, make sure that you have what's called a file type detector in play, and that's going to eliminate the possibility that they are uploading these executable files. We're only getting things like JPEGs and PNGs and all that good stuff. Okay, moving forward, let's talk about another kind of attack called ARP spoofing. Okay, so ARP spoofing is a technique used by the attacker, by which an attacker sends a spoofed address resolution protocol into a local area network. Okay, so generally the aim is to associate the attacker's MAC address with the IP address of another host, such as the default gateway, causing any traffic meant for the IP address to then be sent to the attacker instead. So in a nutshell, you can really think of ARP spoofing like an interception in football, right? Where the ball is our request and we're sending it and it gets intercepted, right? So to prevent against this, we can use the TLS certificate, right? So redirect our traffic from HTTP to HTTPS. So we have nice encrypted channel. Another kind of spoofing we can talk about is DNS spoofing. Okay, so it's a form of computer security hacking in which domain or corrupt domain name system data is introduced into the DNS resolver's cache, resolving the name server to return an incorrect IP address. This results in traffic being diverted to the attacker's computer or any other computer for that matter. Okay, so this is a lot less common because DNS providers typically have a lot of security protocols in place already to prevent against this. But in any case, once again, the TLS certificate and redirecting our traffic right from HTTP to HTTPS is really going to go a long way in helping us out. All right, now let's talk about a firewall. Okay, so a firewall is a network security system that monitors and controls the incoming and outgoing network based on predetermined security rules. It's always a good idea to make sure the machine your server is running on has one set up. Okay, and of course this is more important for higher traffic applications, but nonetheless, most computers, most servers are going to come with a standard setup. So if you don't know too much about setting them up, don't worry. You more than likely already have one set up, and really it's a one-time thing. So moving forward, let's go ahead and talk about having a plan B in the event of an attack. Okay, so no system is completely 100% secure, so it's a good idea to back up your data and your OS in case of an emergency so your service is not interrupted for your users. Okay, so think of something like Facebook, right? Do you think Facebook just never has outages on their servers, things like that, right? They do, but they always have a backup plan in place to where their customers are never notice those system issues. Because their plan B is so good. Okay, and that's what you want to do for your own software, is make it to where in the event your system A is brought down, you've got system B ready to go. Okay, So as well, it's a good idea to have an emergency checklist in place in case of service outage so that corrective action can be taken immediately upon discovery of the issue. Okay, moving right along, let's talk about organizational privileges. As there's oftentimes a large number of hands involved with building a single software project, it's a good idea to restrict access to things on an as-needed basis. For instance, a developer may have access to modify the code, but not to modify or touch the production servers. And the operations team might have access to modify the server environments, but not the code. Okay, and this is really important because, people quit jobs all the time, people get fired, right? Developers included, and there might be some, some tension or whatever else it may be at the end. And last thing you want to do is have one of your employees the last day of the job go in and just nuke your system, right? So only give out those specific permissions to individuals you really trust, and that you're not afraid might compromise things on a bad day. Okay, now let's talk about protecting passwords. Okay, so I'm just going to start by saying there's several ways to do this. Okay, several languages, several approaches. So what we're going to talk about is a technique called salting and hashing. Okay, so when encrypting passwords, the first thing we're going to do is we're going to take our password, we're going to add a salt. Okay, and a salt is a long random sequence. And then we're going to use a hash algorithm to hash it. And what this does is it does two things. It makes it nearly impossible to guess the password without knowing the salt. And even if the attacker gains access to the salt, they won't be able to use the pre-computed hash to get the password out. They'll have to compute the entire space from scratch. Okay, and this makes it to where we never have to store the actual password itself in the database. We're just storing a hash. We're using that salt as the kind of decryptor key to help us out. Okay, and also as well as encryption, it's also a good idea to enforce some sort of password strength rule. Right, you've seen these in play with a minimum of 6 characters. You must have a special character, whatever it might be. But it's better to enforce something like that than just to let them do any password, and then there will be really easy guessing, especially in brute force attacks where they just literally go down a list of passwords that are common. So making it to where your users can't use very common passwords is a good thing. Alrighty, so now let's talk about two-factor authentication. Actually, before we do that though, let's go and open up the floor and let's see if anyone has any questions so far. Okay, so the floor is open. If you have any questions, you are free to ask them now. Okay, no questions so far. Okay, all right, let's go ahead and move right along then. So next we'll talk about two-factor authentication. So have you ever been asked to enter a code sent to you on your phone as a text message? Okay, so that is two-factor authentication. This increases the difficulty for an attacker because they would have to compromise more than one device in order to successfully impersonate a user. Okay, so people lose devices all the time, right? You might lose your mobile device, you might leave your laptop at the airport. Whatever it is, the last thing you want is someone to be able to find that device, log into your maybe bank account, for example, and then go to town, right? So instead, what a lot of these banks and more sensitive, I would say, software is they enforce this two-factor authentication to where it makes it a lot harder if someone maybe just loses one device for the person who found it to gain access to their accounts, right? They have to have more than one of their physical devices in their possession, which is really unlikely. Okay, so depending on the kind of software you're building, you might want to enable two-factor auth. All right, so let's wrap up by talking about security resources. Okay, so this first one's called CVE, Okay, and this is a government-maintained database of incidences. Okay, so you can come here and you can keep up to date with the latest reports. Another one is called OWASP, and this one is very much like Wikipedia. Lets you look over different incident types and all that good stuff. And then third one here is Verus, which is just a community maintained database. Just has a bunch of reports similar to NVD, so you can always come here and read up and implement those latest greatest prevention methods. Alrighty, so that's about it. Let's go ahead and let's open up the floor again, see if anyone has any last questions. Okay, so the floor is open. You are free to ask away. Going once, going twice. Alrighty. Well, thanks again, everyone, for coming. Have a great day and happy coding.